All right, welcome back to my channel, everybody. In today's video, we're going to be taking a look at power series and the convergence of power series. Specifically, we're going to be looking at a problem from the March 2012 comprehensive exam. And this one is question number 4. So the question states, determine the radius of convergence for the series, the summation from n equals 0 to infinity of nx to the nth power over n factorial. And let me actually turn my screen this way so we have a better view. So here is our series. And as you may know, a power series can be expressed as such. So starting from n equals 0, which is kind of our constant term, right? And going all the way to infinity, it can be expressed as a sub n times x to the n power, right? So it's almost like this infinitely long polynomial, and it will converge to a different function. Obviously, we're actually not really concerned with what function this is converging to. We are more so concerned with for what values of x does this converge. And there's actually two major ways that you can find it. They're pretty much mathematically equivalent, but I will show you the way that I was taught, and that is to look specifically at this a sub n term. So if we distribute everything out from our exact series, we see that a sub n is clearly, right, n to the n, right, because the x to the n is not part of the a sub n. That's how we're treating this, over n factorial, right? And so step 1 is to find this limit. Step 1 to determining the radius of convergence. So we're going to find the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And you might recognize this limit because it's actually part of the process for using the ratio test to determine whether or not a series converges. You can also use it in this instance when you're trying to find the radius of convergence, right? Because we know that it's going to converge for all values that are less than 1, I believe. Wait, is it greater than 1 or less than 1? Yeah, I think it's less than 1. Sorry, my memory's not very good. Anyways, substitute everything in. Because all of the terms are positive, we don't really need that absolute value sign, right? We can kind of just get rid of that. But what this is going to turn into is n plus 1, right, to the power of n plus 1. Maybe I'll put that in parentheses as well, over n plus 1 factorial, right, plus 1 factorial. And then that's going to be divided by n to the n over n factorial. And because we have a fraction over a fraction, that can be a little bit nasty. Let's simplify things. That's going to be, sorry, the limit. Always make sure you remember the limit symbol. I'm notorious for dropping that early, but a lot of teachers and schools will take off points for that, right? So that's going to be n plus 1 to the power of n plus 1 over times, sorry, n factorial, over, right, n to the n times n plus 1 factorial. Okay, so a whole bunch of things are going to cancel out, right? So what is this going to be equal to? Let's take a look first at the n factorial and the n plus 1 factorial. Well, what is the top term? That's just going to be n times n minus 1 times n minus 2 all the way down to 1, right? That term right here. This term is going to be n plus 1 times n minus 1 times n minus 2. So all of the things after n are actually going to cancel out. So that's just going to leave us with the following. N plus 1, right, to the power of n plus 1 divided by n to the n times just n plus 1 on the bottom, right? And so actually, right, we see that there is a term here and a term here, right? We can actually cancel out one of these, right? So what this is going to turn into, and I forgot the limit sign, maybe I'll quickly write that in, but here I'll be better about writing it. The limit, right, as n approaches infinity of n plus 1 to the n, right, because n plus 1 minus 1 is just n plus 1 to the n, right, over n to the n, or the way that I'd like to write it is the limit as n approaches infinity, right? Of n plus 1 over n to the power of n. So if you immediately plug in infinity for n, which you're never really supposed to do, but you'll see here that we're going to get an indeterminate form, right? It's not just going to go to 0 or infinity. It's going to go to 1 to the infinitieth power. We could take the ln of both sides and bring down the exponent and do that whole mess of things. Or we can realize that we can rewrite this. And this is where you have to get a little bit clever. You can rewrite this as, if you break that fraction up, 1 plus 1 over n to the n power. And by definition, right, this is e, right? By definition of e. So we get that L, which is our limit, we usually call that capital L, is equal to E. And the radius of convergence, R, is given by 1 over L, always, right? Actually, 1 over L, which is equal to 1 over E. So because if we look at this series, this specific one, that's going to turn into x to the n, which is the same thing as x minus 0 to the n, right? This thing is centered at 0. So this is the radius of convergence. If you gave this as your final answer right here, you'd be fine. But if you wanted to go a step farther and find the interval of convergence, you could say that it's 0 minus 1 over e, 0 plus 1 over e, right? Because that is the radius. And in one dimension, a radius is just a length on either side. It's an interval. So, right, this is your radius. You would have to individually test the endpoints to see if they converge or not. But this is your preliminary interval of convergence. So with problems like this, I would say be very careful, right, as to whether they're asking for just the radius of convergence, which they're asking for here, or if they are also asking for the interval, because the interval has a couple extra steps, including testing those endpoints, because you're never going to fully know, right? You always have to test them. So as always, let me know if you have any questions about this problem. I realized that this one was a little bit more simple than the ones I like to tackle, but I thought, you know, it's very important to talk about sequences in series because they show up in almost every comprehensive exam. So hopefully you found this video helpful, and yes, I will see you tomorrow.